Today we are going to discuss about class 9 chapter work and energy. First of all, let us discuss about what is work. When we are applying force to any substance, the substance get displaced. Then we can call it as a work done. So, work done by a force acting on a object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. That is, work is equal to force into displacement. Work has only magnitude and it has no direction. If force is 1 Newton and the displacement that is S is equal to 1 meter, then the work done will be 1 Newton meter. The unit of work is Newton meter, or it can called as joule also. According to the direction of displacement, work can be divided into two, that is positive and a negative. When the force is in the direction of the displacement, then we can say the work done is positive. And when the force applied is in the opposite direction of displacement, then we can call it as a negative work. This is the symbol representation of positive work and a negative work. In the positive work, the object is moving in the same direction as that of the force applying. There is no friction or nothing is there. But in the negative work, there is friction is applying in the opposite direction of the force. So it is called as negative work. This is energy. The energy possessed by an object is the capacity of doing work. The unit of energy is same as that of work, that is joule. And 1 joule means the energy required to do 1 joule of work. There are different kinds of energies are there: kinetic energy, potential energy. These all are called as mechanical energies. The kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed. When the object's speed increases, automatically its kinetic energy will increase. Here are some examples of kinetic energy is given here. All the objects are in moving position. We can find out the kinetic energy of an object with the mass m and moving with a uniform velocity v. We can use this formula half mv square. Next type of energy is the potential energy. The potential energy possessed by an object is the energy present in it by virtue of its position or configuration. Here some examples are given below. When we consider the position, when the object is at a particular height, then it will gain an energy. That is, this kind of energy is also called a potential energy, or maybe it's in the configuration. Let us consider bow and arrow. By its configuration, it will gain some type of energy. This also called as potential energy. When an object of mass m is placed in a height h from the ground, then the potential energy we can find out by using the formula mgh, where g is the gravitational force. Next is law of conservation of energy. Energy can only be converted from one form to another. It can neither be created or destroyed. The total energy before and after the transformation remains same. This is called as law of conservation of energy. The law of conservation of energy is valid in all situations and for all kinds of transformation. Here in this section, the cyclist is in the stationary position. That means the kinetic energy, that is, the object is not moving. That's why the kinetic energy is zero, and the object is in the stationary position in the ground. So height is zero. That's why the potential energy also zero. From here he starts riding, so the moving part will always have kinetic energy, so his kinetic energy also increasing. And when he is moving up on the hill, the height is increasing. From zero, when the down portion, its the height is zero, and when he is going up, the height is increasing, so the potential energy also increasing. Here the cyclist is at stationary position, so kinetic energy is zero here, and the height is maximum at this point, so the potential energy is maximum at this point. From this point, the kinetic energy is going to increase, because from zero velocity to maximum velocity, the cycle will attain. That's why the kinetic energy is slowly increasing. And according to the potential energy, it will decrease, because from maximum height to minimum height it is attaining. That's why the potential energy is decreasing and the kinetic energy is increasing. When the cyclist reaches the ground, the height will be zero. Here in this position, the height is 0, so potential energy is 0 here, and kinetic energy will be maximum because the velocity is maximum here in this position. The sum of potential energy and kinetic energy of an object would be same at all points. That means potential energy plus kinetic energy equal to constant at all points. The sum of kinetic energy and potential energy of an object is called its total mechanical energy. From this picture, we can say that during the free fall of the object, there is decrease in the potential energy at any point in the path appears as the equal amount of increase in kinetic energy. There, thus, the continual transformation of gravitational potential energy into kinetic energy. Here, we are neglecting the air resistance on the motion of the object. Our last topic is power. Power is defined as the rate of doing work or rate of transfer of energy. Power can be found out by using the formula work divided by time.